Okay, so we're going to mount the sample on the sample stage. Keep the sample stage in this drawer. We're going to use this multi-mount holder. We're going to mount the stage onto the holder by setting it in the center and then tightening the set screw on the side. And you want to make sure the set screw is very tight so that the stage will not drift at all. It's also important to make sure that the stage is the correct orientation, so the flat side of the holder is the bottom, and then the Faraday cup and the gold standard should both be on the top. And then we're going to make sure that the chip is set on the holder in the correct orientation, the top of the chip towards the top, approximately just below the Faraday cup, a little bit to the side. And then you clip on the chip as carefully as you can by lifting up the clip, rotating it a little bit over to the side by pushing it. It's much easier to push the clip than it is to pull, and then setting it down on the corner of the chip. And so you can see I'm adjusting the chip just a little bit because it wasn't quite in the right spot. It's important to try to do this very carefully so that the chip is secure in the correct location. Once it's good, I'm going to make sure that the stage or the holder is not rotating, that the set screw is tight enough, and then we're going to load it in the SEM. So we will press vent. You'll notice the little door pop open just a little bit, and that's when it is vented. And now we're going to load the sample by attaching it to the transfer rod, pressing store, which will pull vacuum in the load lock chamber, and then pressing transfer. Right now it's pulling vacuum. Once there is a suitable vacuum in the load lock chamber, it will open the transfer door. Great, so now we can see the door is open. We can transfer the sample by pushing the transfer rod in and unscrewing 15 times counterclockwise once you have carefully mounted the sample. We'll press store, which will close the transfer door, and that is that. The sample is transferred. Okay, so first things first, we're going to actually make sure that we are in the lit mode here on this switch box. So make sure that's switched to lit. We're going to check that the blinker is on. That's that white light in the back. We're going to open the SEM software, which is the Smart SEM, and we're going to sign into the lit account, which is you can see that I've already opened the project directory for NPGS on the other computer above. And I'm going to just open up some features here on this SEM software. So I'm going to open up the camera, I'm going to open up the store recall function, the external scan control, and the specimen current monitor. I'm also going to turn on the gun control over here, which is on the taskbar. I'm going to use that to just monitor the gun pressure to make sure that as we go to high voltage, we don't see any spikes in the pressure that would mean that something is wrong with the emitter. So I'm going to press resume, and I've loaded the stage in a already stored position. So when I turn on the current, we're going to be looking right at the gold standard, and we're going to be about approximately 4.2 millimeters working distance away. That's the stored position that I've loaded. You can see that I can't see anything, and so I'm turning on the high voltage to 25 kilovolts. And you can see that I can't see anything on the scan window. That's because sometimes the software glitches and I need to first go up to the top computer and put it into NPGS mode and then back into SEM mode. And then now my scan is working. So we're at 25 kilovolts, and we just want to get up to 30 kilovolts relatively slowly. We don't want to go right to 30. So we start at 25, and I will adjust the focus at this point because that will, the focus essentially changes the working distance, which is the same for all voltages, but as we change voltage, the stigmation and the other parameters for the aperture will change. So I won't do any of the other adjustments until we get up to 30 kilovolts. So I'm going to go to 28. Again, I'm just watching the gun pressure over here, making sure that it sort of settles at very low pressures in the -10 range before I go up to a higher voltage, only going up about 2 or 3 kilovolts at a time. And then I'm going to eventually go up to 30 kilovolts. So we go to 30. I'm on the 7.5 micron aperture. I've adjusted my brightness and contrast so that I have a clear picture. So those brightness and contrast values are somewhere around 46 and 52% respectively. So those will be sensitive to what detector we're on. So we're on the SE2 detector, by the way, and also what aperture we're on. So we're using the 7.5 micron aperture. You can see I'm just adjusting brightness and contrast now until the image looks good. I'm zooming out, and I'm going to pick some small gold particles to focus to with this 7.5 micron aperture, so I can do a sort of coarse adjustment of the aperture. So I'm adjusting the focus. Once it's okay, I will turn on the wobble feature, which periodically brings the focus in and out. And you can see as I move the aperture in Y and X directions, we can see it move in X and Y directions. The goal of this is to turn on the wobble and see that the focus only looks like a heartbeat, so that the gold particles are not moving back and forth, but just sort of pulsing. So that's what it should look like. So I'll turn the wobble feature off now. The aperture is aligned. And now I just want to make sure the stigmation is good and the image looks crisp, so I will not touch the stigmation for now. We will do some fine-tuning of that later on. I'm now going to switch to the other aperture that I'll be using today, which is the 30 micron aperture. And so this, you want to tune up all apertures that you'll be using today at the gold standard, or that you'll be using for your write. So I will be a little bit quicker while I tune this one up, because I'm only going to be writing some of the larger features with this aperture. So I'm going to tune the focus very quickly. The aperture seems very aligned, and that makes sense because it's a much bigger aperture, so it's a little bit more robust there. And I'll just try to adjust the stigmation a little bit. So I'm just adjusting the stigmation and the focus, and it's not going quite great, so I'm going to just make sure the aperture is still aligned by turning the wobble back on. It seems okay. If I intentionally, I'm going to intentionally unalign it, you can see it wobbling back and forth, so the X was good. I'm going to put it back so it's aligned properly. I'll do the same thing in the Y direction. Again, you can see it starts wobbling, so it was seemingly aligned. When it's tricky to do this, you can actually hover over this icon. There's an autofocus, auto stigmation algorithm, and if you right-click on it, it will autofocus and auto stigmate the aperture. It only takes maybe about a minute or so. This works certainly well enough for the large aperture that we're going to use for writing. And this algorithm seems to work better if you are close to properly focused and stigmated. So you can't just be sort of out in the blue and then press this button and expect it to work. But once you're close, using this can speed up the process. Okay, great. So it looks like the 30 micron aperture is now properly tuned. So we're going to go over to the Faraday cup and measure the current in both of the apertures. So the Faraday cup is just to the left of the gold standard. We're going to zoom in on the center so that our entire screen is just filled up with this black space in the center. And then we will turn on the spot beam over here on the specimen current monitor, and we'll turn on the current monitor itself. And I'm going to record the aperture alignment and stigmation values for both apertures, which you can get by clicking on the aperture tab and then clicking on either stigmation or aperture alignment respectively. And then I'm also going to record the current value, which for the 30 micron aperture should be somewhere around 450 picoamp, and for the 7.5 micron aperture I expect it to be somewhere between maybe 16 and 18 picoamp. Okay, great. Now that we've recorded all of the aperture values and the currents, I'm going to, before I forget, input these currents into the different areas in the file where they belong. So I'm going to make sure that all of my pattern and alignment entities in the run file have the proper currents for each part of those entities. Once we have input all of the current values into the run file and we've tuned up the apertures, we can start moving our way to the chip. So I'm going to turn on the crosshairs from the view menu at the top, and I'm going to start driving straight down and a little bit to the left of the Faraday cup until I see the clip using to hold the chip. That's what was just on the screen a second ago. And I'm going to see the top edge of the chip, and I'm going to slowly move to the top left corner of the chip, being very careful not to expose too much of the chip because it will have resist. And then I'm going to start moving inwards until I get to the gold sort of alignment trench along the side of the left side of the chip. I know it's okay to expose this area because I'm far away from my pattern here. And I'm just going to do a bit of an alignment correction here at the chip where I try to drive in a straight line down the chip, and if the chip is properly aligned to the axes that are defined by these crosshairs, as I move down the chip, I should just stay along the left side of this trench, and I'm just going to adjust the rotation as I go. In other words, I'm just going to correct the rotation of the chip so that it's approximately on the same axes as the crosshairs. I've also changed the working distance to be 6 millimeters, so I know that if the gold standard is in focus at 4.2 millimeter working distance, my chip is about 1.8 millimeters less thin or less thick than the gold standard, and therefore I'll be at the proper 6 millimeter working distance here for this write. So I'm still just driving down the chip and adjusting the rotation, and you can see as I drive straight downward, my crosshairs are pretty well centered right on the left side of that gold line, meaning that my chip is properly rotated. So once I get all the way to the bottom of the chip, you'll see these a couple patches of gold. This is from where I found burn spots when I was doing the alignment marks on this chip. And I'm going to use these patches of gold to do two things. One, I'm going to adjust the focus of the apertures here. So I'm going to turn off the crosshairs. I'm going to switch to the 30 micron aperture, and I'm going to adjust the focus of this so that I'm in good focus. And then I'm going to use the intersection here, and you can use other features on the chip as well if you don't have these, but I'm going to use these to measure the offset between the two apertures at the two magnifications that I plan on writing at. So I have a run file designed for this, so I'm going to line this up and run this run file. So this run file works by essentially running an alignment process where I will align this crosshairs that it's at a certain point, and then it will switch magnification and switch apertures to another setting that I plan on writing with, and I will align the aperture again and record the distance between those two settings as the offset that I intend to measure. So once it gets about halfway, I know it's probably scanned the thing that I want, so I'm going to press B to blank the beam, and then it will adjust the brightness and contrast settings. I'll align the crosshairs with a certain point, and I'll press Enter and then Y to store that as the alignment value. And then I'll start this second alignment procedure. So now it's scanning with the 30 micron aperture. And the color scale is much more sensitive on this larger aperture because it's getting a larger signal, and so I'm just adjusting the contrast, increasing it or decreasing it depending on whether or not the image is coming in too hot or cold, so that I have good contrast in the image that I'm getting now. And this is just because the red and blue scale, color scale, is set to what it picked up on the previous image which was with a different aperture. So once the point that I chose in the last image comes in, I'll pause the scan again with B, I'll move the marker there, and I'll record the X and Y offsets in the lower right of the screen as the offset for these two apertures at these two magnifications. Now I'll just press Escape to get out of this run file. And I'm going to immediately input this offset into the run file in the appropriate spot, which is in the third part of the pattern entity for this specific run file. So this is after it writes the small patterns using the 7.5 micron aperture at a large magnification. It will switch to the 30 micron aperture at a much smaller magnification to write the larger stuff, but it needs to know about this offset between the apertures and magnifications in order to do so. So after that, we're almost ready to begin writing. So I'm going to turn off the crosshairs. I'm going to make sure I'm on the 7.5 micron aperture, and I'm going to drive to what we refer to often as the sort of reference cross, which we use as a common launch point to other locations on the chip. So this is the reference cross for the lower left pattern on the chip, and we're almost ready to write. Okay, so to begin writing, the first thing we want to do is do a more fine-tuning of the beam that we want to write with. So I'm going to zoom in on the lower right corner of this reference cross a lot, so that I'm not exposing too much of an area. And then I'm going to pause the scan, and I'm going to move to the burn spot box using a run file that just moves the stage a certain distance to the burn spot box, and I'm going to make sure I watch the stage on the camera and see that it moves. Once it's there and the run file closes, I'm just going to start the scan again, and I'm going to be very quickly zoom in on the burn spot box, make sure I don't expose too much of the resist in this area because we're very near where we're going to pattern right now. And I'm going to zoom in on just this very small cross right in the middle. So this cross has 50 nanometers or so width lines, and so it proves to be a very effective small feature to focus to and to get a very nice clean focus of the aperture. And so now I'm just turning on the spot beam for this aperture, and I'm trying to make a burn spot. You can see after I turn on the spot beam for about 10 seconds, I have a nice crisp burn spot, and I'm just going to use that burn spot to focus to, so I'm just adjusting the focus. This burn spot is about maybe 30 or so nanometers wide in diameter, to give you a reference scale. And I'm just going to, again, use it as a very small thing to focus to, so it should look as ring-like as possible and hopefully as circular as possible. So since it wasn't quite perfectly circular, I also adjusted the stigmation a little bit, and now once I think I've gotten the focus and stigmation pretty good, I'm going to make another burn spot for maybe about 5 seconds or so, and you can see the next one is a little bit smaller, maybe a little bit more circular. And so this is just sort of an iterative process of making burn spots, adjusting the focus and adjusting the stigmation until you have it just quite right, which is sort of a 20 to 30 nanometer wide, very circular ring-like burn spot. So you don't want to spend too much time here because, again, we are exposing resist that's very close to the pattern. So hopefully you can do this maybe in about 3 to 5 minutes at an absolute maximum. So after I've spent a little time here and made a few burn spots, we'll go on to patterning. Okay, I'm happy with the way those burn spots look, so I'm going to just center on this cross again, and I'm going to use this as my reference point. Or my run file at least assumes that I'm at this location, so I'm going to pause the scan. I'm going to make sure I enter NPGS mode, and then I'm going to process the run file and press yes. The first part of the run file is just making sure I'm in NPGS mode, which I am, and then I will press space to continue, and it will move the stage to the center of the pattern. So now the beam is blanked, but it's directly over where I plan on patterning. And I'm recording the stigmation I found for the burn spots, so this will be hopefully good for the rest of the day. And I'm just recording that value in case I accidentally bump the stigmator. I know how to get back to a decent set of values. So now we're waiting for the stage drift for about a minute. So there wasn't much stage drift today, so I maybe waited about 30 seconds. And then I press go, and we're going to start the first alignment process. So it scans a set of coarse alignment marks at a relatively small magnification, and as soon as I can see each piece of these coarse marks, I'm pressing B to pause the scan just to make it go a little faster. And I'm just doing a relatively quick job of measuring these marks, then pressing Enter and Y to align to them and move on to the medium marks. So now we're at a higher magnification, and we have these medium marks. Now there's a sort of systematic offset in the SEM, and it's quite large, at least during the write that I'm doing today. So I know I have to misalign these marks by about 1.5 microns or so to the left in X. So I'm just aligning them all individually, and then just making sure I'm about 1.5 microns misaligned in X. This is not usually this bad, but the SEM is definitely due for some service at the time this video is being recorded. So hopefully on your day you don't have to do this sort of systematic offset. So I'm doing this with all 3 of them here. Okay, good. Once it's good, I will press Enter and then Y to use that alignment. Now it's on the final alignment step, so all 3 marks come in. I will very quickly press B after the last one is scanned so I don't expose too much. I will press A to fix the color scale, and then the exclamation mark to do an auto align. Then I'll press R to recalculate, and then it will scan all 3 marks again. I pressed B to pause it right after that. Then press exclamation mark again, and then as soon as it's done aligning, I immediately press Enter and then Y. And that immediately aligns and then restarts the pattern, starts patterning using the auto alignment process. So now it's patterning the small features. It displays them. You can see takes about 30 seconds to pattern these. And once it's done, it will switch apertures and magnification and start patterning the large features. So it's now patterning the large features. Depending on your pattern, you may or may not see anything in the display here. NPGS does not display any colored pixels if the dwell time for each pixel is below some threshold number. So just know that you may or may not see the pixels during any of the patterning steps you're doing, but just make sure that if you expect to see them, that you do. And this takes about 1.5 minutes, so from here we just wait. Okay, so it's done patterning. It will move back to the reference cross for this pattern. And then the next thing you do is move up to the next pattern you want to pattern. In my case, I'm going to pattern the die directly above the lower left one. And then move to the burn spot box for this pattern. Make sure you're on the 7.5 micron aperture because your run file may have left you on the 30. And then just very quickly zoom in again on this burn spot box on the little cross in the middle. Again, we're going to find burn spots right here because the focus can change as you move around the chip. But typically, once you have set the stigmation and found nice circular burn spots at one location on the chip, you probably won't need to adjust the stigmation any further. So from here on out, it will probably just be adjusting focus and trying to find a nice focus at each location that you plan on patterning. So I make a burn spot, focus to it, possibly make another one, line up with this cross as a sort of launch point for the run file, enter NPGS mode, and then process the run file. Again, there's an NPGS mode check. I'm going to make sure I mark that I'm writing this specific pattern. So we're above the pattern. I've done a stage drift wait for about maybe 10 or 15 seconds at least. And now we will go through this alignment procedure again, and then go through the patterning again. So just to reiterate, as soon as I see parts of these marks, I press B to pause the scan. This just makes the course alignment go quicker. You don't need to see the whole mark to do it. And again, the purpose of the coarse mark and the medium mark is just to be able to find the medium and the fine mark respectively. So right now we're on the medium marks. It has zoomed in the magnification. And again, remember, this is the step that going from medium to fine, there is a sort of systematic offset right now in the SEM that I'm accounting for. Hopefully this is much less severe on the day that you're running the tool. Just to go through again, what I'm going to do when I get to the fine marks is I'm going to essentially do the alignment twice very quickly. I'll let it scan all the marks once, and then I'll pause the scan with B. Once it's paused, I'll calculate the auto contrast using A, and then I will do the auto alignment using the exclamation mark. Then I'll press R to recalculate all of those. And then once it's recalculated, I'll go through the procedure a second time where I just pause it after it scans all 3 marks, do a more fine-tuned auto alignment by pressing exclamation mark again, and then immediately pressing enter and then Y after it aligns all 3 marks. And that ensures that it sort of is as aligned as possible to, and starts patterning immediately after you do the alignment, so that if there's any drift or so, it is hopefully minimizes the effect. So it's patterning the small features. In about 30 seconds, it will switch to the larger aperture and another magnification, and it will pattern the large features. There we go, switching aperture and mag, and now it's patterning the large features. Okay, and that's all the patterning we're going to do today, so I'm going to press exchange. This will turn off the high voltage, as well as once the voltage is off, it will move the stage to the transfer position. If you wanted to keep patterning, you would just continue on to your next pattern and continue the process, but I've done all the ones I want to do today. Once the voltage gets to 0, I'm going to make sure I set it to 20 kilovolts so that if the next user turns it on without checking what the voltage is, it doesn't go all the way up to 30. This is critically important. I'm also going to set it on the 7.5 micron aperture just sort of to be polite to the next user so that they don't possibly blast their sample with a large aperture. I'm going to use the the NPGS software to put us back into SEM mode, and then I'm pulling out the sample using the transfer rod, pressing store and then vent once I've retracted the sample back into the load block chamber, and then I've closed the Lith software as well as the NPGS software. Now I'm taking the sample out, I'll bring it over here. In fact, I think I forgot to press store, so I'm storing. So this leaves the load lock chamber in vacuum. So you always want to remember to do that. Any vacuum system, it's typically good hygiene to leave it under vacuum. And I'm just going to get the chip off by, again, picking up the clip, pushing it rather than pulling it in any direction, and then making sure it's nice and safe in its gel pack. I remember I also forgot to log off the PPMS system, so I'm logging off here. Remember, we get billed for every minute we're signed in. And then I will just take off the sample holder, put that as well as our own screwdriver back in the box, and put the multi-holder back. Make sure this lives back in this drawer here. And that is the shutdown procedure. Good luck.